is I'm going to teach you the beginning of logs today, and then you're going to go, oh my gosh, there's so many little things about this. But if you can only get one thing down, is that it's a conversion between like this and a log. Because a log can solve that. See, normally we can always solve things. We can just go, oh, I'll just add 6. Or I'll just divide by 6. Or I'll multiply by 6. Or well, maybe I could even put it to the power of 6. Can you think of anything you could do to get that x out of there? What?
Like, put both sides to the x.
Put both sides to the x. Nope, that doesn't get rid of the first x, though.
That's to the x root.
To the x what?
X root. Like a
Oh, to put it to the root of x. Yeah. Interesting. Nope. You can't put it to a negative x. That doesn't work. No.
And you can't just put like a square root sign and put the little x on top.
Nope. So, I mean, that's not a thing. So it's a good idea, though. All right. So let's go back to a million smart kids are stuck. Did anybody at least think, if I can factor it, I should? Okay. And then I hope you looked for that and you're like, well, I guess I can't factor this. Thank you. Find the notes quick. Then, what's the next one on the list? Clear the fractions. Well, there's no fractions. I don't have to clear any fractions. What's the next one on the list? Jacob. Graph both sides and see where they cross. Now that is an outside the box way to do it, and it absolutely would work. Y equals 5 to the x and y equals 8. If I were to graph y equals 8, I hope you all know y equals 8 would just be a line going across at 8 like that. And 5 to the x, that's like this. And they would cross somewhere. And that's an awesome thing to remember. And once again, only one person this time remembered the list of things you can do to solve really hard math problems. What's the first one again? If you can factor it, you should. What's the second one? Clear fractions out. I'd say this is the third big one. And just remember, you can graph both sides and see where they cross. Now, no other teacher is probably teaching this today, but I'm trying to pound in a point that when you have a really hard math problem, this solves it. Like, this would work. It's not supposed to be the lesson for today. But I'm just bringing it up to remind you, if you have a really hard equation to solve, graph both sides, see where it crosses. All right, but let's get back to how I'm supposed to be teaching you to solve this, because this is also a good way to solve it, and that is by doing logs. And you've never done a log. You have no idea what a log is. And so you've probably seen it on your calculator. Have you seen the button called log? Probably wondered what the heck that's for. All right, so I'll tell you today. Yes?
I thought we did a unit of this entire algebra.
Oh, maybe you did.
Yeah.
Oh, good. Good, okay. Awesome. I thought that got kiboshed. So, all right, so, yay, maybe you'll remember this. This is trying to figure out what decimal that would be. Would you agree 5 to the 1 is not 8? How about 5 to the 2?
No.
Oh, that's too big. So you agree it's between 1 and 2? Got to be 1 point something, okay? Well, then to get the exact answer, I'm going to rewrite this as a log. So this is called the base. Would you agree? Do you remember that terminology? Base there? This one's exponent. Okay, the base and the exponent. And the third number is just a number. I guess you could call it a base kind of because it's got an 8 to the power of 1 on it. But all right. So the log base goes right here. We need 3 numbers. One goes here. One goes here. And then you always say equals, and then you have a third thing that goes here. Just highlighted those areas to show you. And this is where the base goes on a log. And this is the exponent. And this is the one that doesn't show up over there right now because as having a name. And it's called the argument. I'm just going to abbreviate it, arg. So, base is 5. Log base 5. Of the argument, well, we could argue what this is called. Get it? Yeah, it's the argument. And then last is the exponent, which was over here. Look, see, exponent was x. Log base 5 of 8 equals x. So, if you had a calculator, you could type in log base 5 of 8. What is it? In the old days, they used to just have a chart for it. And what logs really are is the right exponent to solve the problem. Logs really are exponents. And it's really hard to get your head around that, but it's true. Because look, see what this is? It equals the exponent. So logs just really are ways to get the exponent. Yes?
That's 1.29.
Thank you. So the answer ends up being 1.29. So that means 5 to the power of 1.29. And again, it goes on forever and never repeats. So we always just kind of like round it. That equals 8. All right, if you've been paying attention, you should be able to do this then. 6 to the x equals 10. Write that, make a log for it. That's the one big thing for today. If you walked out with nothing else but could change these back and forth, even when they get weird, you got to be able to change them from logs to exponents or from exponents to logs. This is an exponential. I want you to make a log for it. In a moment, I'm going to ask you to compare it with the kid sitting next to you. Please write it out. Don't say it to them. It's hard to process. See if you end up with the same log statement as they do. So back to the log for this. Can you tell me what you think the log is for this? Log base what or what? Okay, so log base 6. And then the way you say the next thing is of 10 equals x. There we go. Log base 6 of 10. Now, I like it when you say equals x afterwards. Do you have to? No. You don't actually have to say equals x. But I'm warning you, on the problems that we do, you're going to want to. Okay, so it's best to finish with that. Equals x. That way you got all three parts. This, and this. They're just rearranged. And I really need you to understand how to say these. I'm going to say this one more time. I'm going to include the words here. You say this as base, log base 6 of 10 equals x. And what are their names again? Well, the base. And this is the exponent. And this one's called the, what's this one called again? The argument. Let's see if you really caught that. How do you say that properly? Think it. Think how to say that. Isaac, say it properly.
Log base 3 of 7.
Log base 3 of 7. Very good. Okay, now what's the exponent for that? It's like Jeopardy. I just gave you the answer. What was the question? Yes, sir.
It was 3 to the x equals 7.
Good. My 7 got weird. Second here. Okay, so I want you to notice this circle. And you might be like, oh, that's easy. When they get weirder, you have to still be able to do that loop. And the circle of logs is what I like to call it. All right, so here's them getting weirder. X plus 7 to the third equals 4. Could that be a log? Yeah, anything. Anything that's an exponent problem can be written as a log. That'd be log base what? X plus 7. Of what? 4. Equals what? 3. See, it went from there to there to there. The circle of logs, around the horn. Now, which one's better? Because usually we are going from one to the other. Which one's better? The blue one or the black one? Well, better is kind of in the eye of the beholder, but which one would be easier to solve?
If you're going to
The blue one, that's a good question. You can't put the black one in the calculator.
Oh, yeah, sure.
But the question would be, can I use a calculator or not? Okay, but either way, in this case, the blue one's faster to solve. You know why? Because from here, I could get rid of the power of 3. Those aren't that hard to get rid of. Variables up there are hard to get rid of. But how do I get rid of a power of 3? I put it to the 1/3. Both sides. And do you get that cancels this out, turns it into a 1? And then you just subtract 7 and you're done. So it really comes down to which one's easier to solve. So I go back to the thing I taught you at the beginning. And this. Log base 5 of 8 equals x. Which one's easier to solve?
Bottom.
A, B. B is solved.
Yeah.
The x is already alone. You just have to know what that is, which you could use a calculator or a chart. Back in the old days, they had a thing called the slide rule. Hard to believe, but the guys that were launching rockets to the moon were using slide rules. They did have some computers, but they were still people who had been trained with slide rules, so they want to do a problem quick, they just use a slide rule. It was actually super special if you got to use the computer. That was like special to go in and we get to solve this problem using the computer. Yes?
Is it like, it kind of looks like a ruler, but it has like a bunch of different numbers on it?
It's like a ruler, except it has a sliding middle part.
I
Yes. They're good piece of history. They actually would work for this. You could do logs with them. Okay, so anyway, which one's easier to solve? Well, the B, this one in this case, the B was. All right, how about this? Log base x of 4 equals 5. Does that look easy to solve to you? Can you just do something and then the x is alone? No. So, rewrite this one. If you're rewriting it, you won't have a log anymore. Amelia, what do you think it is? What to the what equals what?
X to the 5th equals 4.
Perfect. Goes around the horn like this. And why is that easy to solve? Because there's one step. What would you do to solve that? Put it to the 1/5. Because then the 5 and the 1/5 just they're gone. And x equals 4 to the 1/5. All right. Next thing is you got to remember a few things about powers. 2 to the negative 1. Do you remember what a negative power does? Well, if you do, you'll know what 2 to the negative 1 is. What's it equal to? Maybe you don't remember negative powers. You remember negative powers? 1/2 is correct. When you put it to the negative 1 power, I like to say it makes it flip. But how do you flip a 2? Well, it's really 2 over 1, isn't it? And then you flip it and it becomes 1/2. Okay, so what's 2/3 to the negative 1 power? 3/2. What's 2/3 to the negative 2 power? I like to think of it as two separate things. It's flipping and it's squaring. So what would this one be? 9/4. Very good. Okay. So I see some of you have remembered your exponents, which is good. All right, now let's get to the next slide. The secret to logs is converting back and forth. A couple other things to remember to mention. Arguments have to be bigger than 0. This right here can't be 0. There'll only be positive things there. It can't be negative and can't be 0. And the bases have to be bigger than 0 also. So both this and this have to be bigger than 0. They can't be 0. If you ever see this, log base 0, you know it's a trick problem, and the answer is no solution. Even log base 0 of 5, No, you can't do it. It's not allowed. It's like having a 0 on the bottom of a fraction. You just can't do that. All right. So how about a 0 there? Can't have a 0 there either. They have to be positive numbers. All right, there's one more thing that's a little minor league annoying about logs. And I wish I could just say that both the base and the argument just have to be bigger than 0. But you also can't have a base of 1. Log base 1 not allowed. I'll show you that. Log base 1 of 4 equals x. Just imagine we could do that. Okay? Now it means 1 to the x is equal to 4. How you going to do that? 1 to the what power would equal 4? Feels like you should be able to do that, but you can't. Do you get if you go to the second power, it just stays 1. What if you put it to the 1/2 power? That means the square root of 1. Still 1. So 1 is not a good base. So they just say you can't have 1. And usually there's some smart kid who goes, what about log base 1 of 1? Okay, because that's the only time it ever works, it's not allowed. It'd be like, how about this? Should we allow people to drive backwards down the highway? No. Could you do it?
Yeah.
Yeah, but it'd be really stupid. It'd be really increase the chances of bad things happening. Okay, so they just say, you can't do that. All right. Common log. If I just say log of 3, it's like the scientists that were writing these, a lot of times it was scientists, got sick of writing base 10 because they used it so much. So that's called the common base. It's called the common log. If they don't put a base down here, they mean base 10. You know, your math teachers do that too. If I say square root of 9, you can assume that I mean the square root of 9. Technically, there's supposed to be a little 2 there. When you do cube root of 9, that's more unusual. So your cube root of 27, for instance, that's more unusual. You can't just assume people would know you meant to the 3rd root. So we say if it's so common to say square root, you don't even have to put the 2. It's so common to have base 10 logs that you don't even have to put the base. If you don't put a base, we'll know you meant base 10. Okay. And then last is natural log. Ever seen that button on your calculator? ln. And I encourage you, try to remember this. Whenever you see ln, you're going to write log base e. So many things to learn in this first day. I'm not expecting you to be an expert, but just know that there's 2 weird logs. A log with no base, which really means log base 10, and a log with a base of e, which is ln. Natural log. It's almost like they're saying log natural. Why? It does come up in nature. It's complicated. I could spend 2 days talking just about e, but I can tell you it's about 2.718. And it goes on forever, like pi. And there's also a few other weird ones like that, like there's one called phi, which is the golden ratio. But e is a big deal in calculus. You'll see more about it there. For right now, just know that natural log means log with a base of e, which is a number, not a variable. It's a number. It's a number that's found in nature, kind of like pi. All right. So I said if there was only one thing you could do, it would be able to rewrite things. Can you please try this one and rewrite number 1? If it's a log, make it not be a log. If it's an exponent problem, usually you solve them by bringing in logs. This whole unit is about that. If you don't see a log, you're probably going to have to put it into a log. If it starts out as a log, you usually have to do something to get the log out of there. In a moment, I'm going to ask you to compare number 1 to the kid sitting next to you. So please, number 1, rewrite it as an exponent. Like 36 to the second equals, but that's wrong, of course. Okay. All right, compare with the kid next to you, please. All right, you should have said that it was 6 to the second equals 36. Is that a true statement? Yeah. So this is a true log. What would this equal? If you put it in a calculator, think about it. What would it equal? It would equal 2. All right. Is this really true? Well, let's rewrite it and find out. It'd be 14 to the what? Negative 2 equals 1 over 196. Well, that negative means 1 over, right? And how about the squared? Doesn't 14 squared 196? So, it's true. Worked. All right, let's do go to 13 though. They got 2 variables all of a sudden. Would you agree this is u to the negative 16th and it equals v? What's it solved for right now? V. V's alone. All right, this is just a variable. It's got 2 variables. It's kind of like x equals 2y, that kind of thing. All right. Now, here's the kind where they start out without logs. You need to write this as a log. Everybody try number 5. What would the log statement be for that? I hope you said log, and then you tried to think of what base should I have. Oh, this one's the base. Log base 64. And then remember, it goes around in the circle of logs. Log base 64 of 8 equals 1/2. And it does. Because 64 to the 1/2 means the square root of 64 is 8. So it makes sense. All right. Let's do one with variables now. What's the log statement for that? In a moment, I'm going to ask you to compare with the kid sitting next to you. On number 15, write it as a log. Log base what? Of what? Equals what? Okay, compare. Henry, you double duty so Amelia has somebody to compare with? Sure, no problem. Log base u of v equals negative 14. Do you get how there'd actually be a lot of combos of numbers that would work? That's true on equations too, right? That'd be like points on a graph. There'd be a lot of combos that could make this equal negative 14. All right, moving on. Getting the answer. Well, all of this is a reminder that you need to set it equal to x, and then you can rewrite it. Let's rewrite this. 4 to the what? X equals what? 64. Now you might be like, you just made it worse. No, because now I can think it through. 4 to the what is 64? 4 to the third is 64. So what's x got to be? X equals 3. Could you have done that by just doing it some other way? Sure, the answer is 3, and there's another way to get it. You could type it in a calculator. And there's another way to get it. You could rewrite this 64 as 4 to the third. Would you agree that 64 is 4 to the third? Do you agree that 64 is 4 to the third? 4 times 4 times 4? Maybe you don't know that, but it's true. So it's totally fair to replace the 64 with a 4 to the third. And then if you make the bases the same, try to remember this. This is a big one. If you make the bases the same, the answer's already there. What is the answer? 3. See how I made the bases the same? The answer's already there, and it's not one of the bases. If the bases are the same, the answer's already there. So, I know that's kind of a vague statement, but it'll work then in a lot of situations. I know the answer to this already, because the bases are the same. What's the answer got to be? The answer's 4, because the bases are the same. The answer's already there. The answer is 4. Why? Well, watch what happens. X to the 4th is x to the 4th. the circle of logs again. So if the bases are the same, the answer's already there. That also comes in another kind of log. Log, where I say 4 to the log base 4 of 3. I know the answer to that is already there because look, this is a base. And this is a base of its log. This base has an exponent on it of log base 4 of 3. This base is the log base. The bases are the same, so the answer's 3. If you don't get that one, I totally understand. I'm going to write equals x, and then maybe you'll be able to go, okay, log base, what's the base of this log? The base of this log is 4. Log base 4 of, always do the circle of logs, x equals log base 4 of 3. And I know that blew some minds, but x equals 3. Bases were the same. Answer's already there. Give you another one like that. Everybody write this one down. We'll take it a little more slowly. 10 to the log 3. If the log doesn't have a base, do you remember me saying a minute ago, that's just shorthand because it's used so commonly. It's called common log. What is the base that's not here? 10. So another thing I'll tell you is Megan Trainor was right. It's all about the base. So if I am missing that base, then that's really going to be crucial. I put the base in and then I go, base is the same. Answer must be 3. Want me to prove it? Then I'd take this, which technically isn't a log because it's got a power. This is actually written as an exponential right now because that's a base and that's its exponent. And then I go, I'm going to rewrite this as a log. This would be log, and what is the base? 10. And then you always do this circle of logs thing. Log base 10 of 3 equals log base 10 of 3. Oh my gosh, it's true. It was 3. The answer was 3. If the base is the same, the answer is already there. Okay, so on that whole page worth of problems right here, you want to write this so it has the same base. Do you agree that log base 4 of 16 is the same as log base 4 of 4 squared? Can't you just replace 16 with 4 squared? And then aren't the bases the same? So what's the answer? 2. Could you make this be a 5 to a power? Of course you can. 5 to the what? Third. What's the answer? 3. If I had to, I could make you rewrite that and it would be 5 to the third is equal to 125. True statement? Yeah. But wait, Mr. Server, you can't rewrite a 7 into a 343. Sure I can. 7 is the same as 343 to the what?
Third.
Negative would make it flip. We don't need it flipped. 1/3. You saying 7 times 7 times 7 is 343? 49 times 7. Nice. So yeah, even weird things like this, you can make the bases be the same. And then why do we do that? Because then we know the answer. The answer is 1/3. Could you have set it equal to x though? Didn't I start with that? Yeah. Let me just show you that way. What if I say equals x? Maybe you'll like this way better. If that one blew your mind, maybe you like this. 343 to the x is equal to 7. Ew. Then you got to just think through. 343 to the what power equals 7? That's not very fun. Okay, last option. Could you put that in the calculator? Yeah, you could. If you don't know how to put in logs in the calculator right now, I don't care because I don't need you to know that yet. In fact, I think it'll just mess you up more than help you. All right, there's our 15-minute warning. So I need to wrap this up. There's only one last thing that I need to really cover, and that's this. If you have log base 7 of x plus 1, Do you remember me saying that this has to stay positive? Ring a bell? Didn't this have to stay positive too? Yeah, but it's already a 7, so it's going to be positive. But how do I keep that positive? If they ask you for the domain is what can I safely feed this function? Can you safely feed it a -2? No. Why not? Because it'll make it have a negative number there. Could I safely feed it a -1? No. Could I safely feed it a 0? Yes, because as long as it's bigger than 0, then the argument is fine. Okay, so then here's the fast way. X plus 1 needs to stay bigger than, can't be 0, so I can't say or equal to 0. Just bigger than 0.
So X is greater than
X is greater than -1. That's the domain. Okay, so when they give you this, log base 7 of x squared minus 14, what's the domain? Well, you'd say x squared minus 14 needs to be positive, greater than 0. Solve. And that's all you got to do. So the domain questions are actually super easy. They're just checking to see if you know that needs to stay bigger than 0. Okay? You've learned everything that you need to know. Now, the homework for today is got tons of problems. You don't need to do all of them, but you should do a little bit on each page. That's all I have other than handing back the tests, and good luck.